Assalamualaikum warahmatullahi wabarakatuh. Hello, we are from class AS12057 and we are going to present our case study for CHM260 video assignment. Here are the list of our group members and we are going to present our case study on first, the analysis of vanillin in white chocolate by gas chromatography, and second, the determination of vanillin in essential oils by high performance liquid chromatography, HPLC. Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to present our case study of the analysis of vanillin in white chocolate by gas chromatography. I am Yasmin Adriana and I am going to give a brief introduction for this case study. Vanillin is an important flavoring additive in food industry due to its strong vanilla aroma. There are several methods for the detection of vanillin in white chocolate, and one of them is by gas chromatography. Based on the research we referred to, mass spectrometer are coupled with gas chromatography method to identify the vanillin in milk powder from the white chocolate. White chocolate is made up of cocoa butter, milk powder, and sugar. Gas chromatography is one of the most common chromatography used to separate and analyze compounds. According to one of the research, this method is purely qualitative and no report using this method for the quantitative quantification. In this study, milk powder sodium chloride was used and the instruments used are the headspace bottle and MS3 basic turbine mixer. This mixer is used for residential heating or microgas turbine application. It is equipped with a stirrer to prevent phase separation.
Assalamualaikum, my name is Na'alibah binti Azizi and I will explain about methodology. So for the sample preparations, 1.0 gram of white chocolate and 2 gram of sodium chloride were mixed with 5 ml of deionized water in a 20 ml headspace bottle. The solution was made using the MS3 turbine mixer for 3 minutes. For the standard preparations, the vanillin and ethyl vanillin standard stock solution, which were 500 mg per liter, were prepared. 0.05 of the standard solution was dissolved in acetonitrile. Next, 10 ml of the standard solution was diluted with acetonitrile and made the 100 ml. A series of matrix mixture standard working solution were made by progressively diluting the mixture solution with a blank white chocolate mix. The standard curve was plotted with peak area versus analyte concentration after measurement under instrument working condition. So this is the explanations about gas chromatography mass spectrometry analysis.
Assalamualaikum. My name is Soleha binti Asnul. I want to present about result and discussion by gas chromatography. In this graph, according to the law of comparable mutual solubility, non-polar fiber coating had higher extraction effectiveness for non-polar volatile compounds, while polar fiber coating had higher extraction efficiency for polar compound swine. Temperature was set to 70 Celsius. Oscillator rotation rate was set to 500 revolution per minute. Incubation duration was set to 10 minutes and headspace solid phase microextraction time was set to 20 minutes. The effects of 7 different types of extraction fibers on a matrix standard mixing solution were studied under this condition and the findings are presented in this graph. According to the amount of extracted vanillin as represented as the peak area, chromatographic peak resolution and peak shape, the extraction capacity of the 7 distinct types of extraction fibers could be compared. Chromatogram of vanillin mass spectra is shown in the peak 1, 9.647 minutes. The finding shows that the analytes collected from the 7 different types of extraction fibers has distinct peak. The chromatogram obtained fiber, on the other hand, exhibited quite obviously tailing, which most likely due to the high absorbability of the tested component by this form of extraction fiber. When the component content was high during desorption, a hysteresis effect was created, which was greatly reduced when the component concentration was low. Furthermore, high temperatures help extract analytes from the matrix. They also reduce the extraction efficiency by lowering the partition coefficient of the extraction fiber. The peak area changes of the analytes were studied using an extraction fiber at 40, 50, 60, 70, 80, and 90 Celsius while maintaining other parameters constant. The peak areas of vanillin attain their highest value at 80 Celsius according to the result. That's all from me. Thank you.
Assalamualaikum. My name is Nurfar Nabila Zaha with student number 2019278548. Today I am presenting on the conclusion for gas chromatography. In conclusion, an auto-headspace solid phase microextraction and gas chromatography mass spectrometry method is used to determine vanillin in milk powder. By using a simple pretreatment, this method has greatly reduced the interference of complicated matrix in milk powder. The sample spike recovery ranged from 90.0 to 100%, and the relative standard deviation ranged from 1.9 to 5.1%. The limit of detection values were 0.1 mg per kg. Vanillin has demonstrated good linearity in the 0.1 to 2 mg per kg range, with calibration coefficients of 0.992. Gas chromatography is one of the most useful instruments in chemistry because it is simple, sensitive, and efficient in mixture separation. This technique is commonly used in quantitative and qualitative analysis of mixtures, as well as compound purification. Advantages of gas chromatography. Gas chromatography high efficiency enables separation of the components of complex mixtures within reasonable amount of time. Then, gas chromatography has exact quantification, a technique that has many application nodes. And lastly, since mass spectrometer is a non-destructive technique, there are multiple detectors with high sensitivity that can be used in series with it. For the limitations of gas chromatography, the technique is limited to thermally stable and volatile compounds only. Most gas chromatography detectors are destructive. These are the list of references for gas chromatography.
Assalamualaikum. My name is Naaliba Azizi, and the next experiment is the determinations of vanillin in vanilla essential oils by high-performance liquid chromatography. High-performance liquid chromatography (HPLC) utilizes a liquid mobile phase to separate the components of a mixture. Principle of high-performance liquid chromatography. It begins by injecting the solute, which is analyzed, onto the top of the columns. Next, separations occurs as the analytes and mobile phase are pumped through the column. Each component eludes from the column as peak on the recorder. The response of the detector to each component is displayed and known as a chromatogram. HPLC consists of 5 instruments, which are mobile phase reservoir, pump, injectors, column, and detectors.
The methodology for determination of vanillin in vanilla essential oils by high-performance liquid chromatography. In sample preparation, the vanilla has been cured by using three methods, which were by scalding in hot water, sun drying, and microwave drying. The cured vanilla then was fermented and dried in the wind, which will reduce water content from 55 until 65% to 25 until 30%. The vanilla will show the signs stated above when they are dried. The cured vanilla is then taken at random and were used for pre-extraction. The pre-extraction of vanilla is divided into four types, such as Y1, Y2, Z1, and Z2, with respective weight and length. These were used in salt flotation, extraction, and percolation. Extraction procedures. The cured vanilla of pre-extraction Z1 was extracted for 16 hours in the salt sled extraction apparatus with 200 ml of 99.9% ethanol. Then it was transferred to a 250 ml volumetric flask. In the percolation apparatus, the cured vanilla of pre-extraction Z2 was extracted into earthenware flask. The Z2 was immersed for one night and then transferred through a paper filter into a 100 ml volumetric flask. The cured vanilla from the first submerge was pounded in mortar, then submerged in aluminium flask for one night in about 35 ml of 99.9% ethanol. The second submerged cured vanilla was fused with the ethanol from the first submerge using the same paper filter from first filtering. The cured vanilla was rinsed with 99.9% ethanol before being poured into a volumetric flask. HPLC UV spectrophotometric. In HPLC UV spectrophotometry, vanillin was separated on a reverse phase carbon-18 column with methanol acidified water and detected at 280 nm wavelength. The HPLC equipment is from Shimadzu and UV spectrophotometry equipment is from Hitachi. HPLC has a flow rate of 4 ml per minute. For the preparation of standard solutions containing 0.5, 1.0, 2.0, 3.0, and 4.0 ppm of each standard were prepared in 99.9% ethanol. The solutions were kept at -2 degrees Celsius until they were needed for analysis. Spectrophotometric standard solutions containing 1.0, 2.0, 3.0, 4.0, and 5.0 ppm of each standard were prepared in 99.9% ethanol. And lastly, quantification of vanillin content were calculated using the formula stated.
Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Nordanish bin Wan Sahrudin. And I'll be continuing about the analysis part. The analysis consists of results and discussion. Okay, for the table 1, a linear relationships have found between the linear regression equations and correlation coefficients of the vanillin standard as determined by the HPLC technique and the isospectrophotometric assay method. It shows a linear relationships. Okay, for the next parts of the result, we will look at the table 2. Okay, the table 2 shows the amount of percentage of weight by weight of vanillin for 12 samples determined by the two different methods, which is the HPLC method technique and the ISO spectrophotometric assay method. However, the data show that for the 12 vanilla samples analyzed, the spectrophotometric metric assay method consistently yielded higher values than the HPLC method. Okay, for the possible explanation for this is when using spectrophotometric assay method, the vanillin, there is a chance that it might not be pure and mixed with another unknown substances. It causes it to absorb at the same wavelength area that will lead to higher absorption. Even though HPLC technique uses detector UV, but the samples go through C18 column and it is separated before it comes to detector cells. This causes only vanillin to be detected, and this also indicates relative smaller analytical results. However, the accuracy of this method is much better. The uses of UV spectrophotometry can be more accurate if a sample is separated firstly, such as using special chromatography column. This way, we will obtain the same result with HPLC technique with standard deviation less than 1%. Okay, for the analysis part from the table 2, it shows that two different methods can lead to almost the same result if only done by the correct technique. However, in these cases, HPLC technique has the correct reading compared to spectrophotometric method. Okay, for the discussion part, the vanilla has been exposed to various high temperature using various methods to limit the vegetative development and to allow enzyme to generate vanilla juice. This can be seen through table 2 that shows different temperature with different methods have different results. For example, that scalding in hot water, cut cure vanilla and salt slime extraction method have the highest vanillin content, which is 3.56% by HPLC and 3.89% by spectrophotometry method, followed by drying in the oven, which has 3.20%, 3.072%, and drying in the sun, which is consists of 3.20% and 3.72%, and lastly 1.82% and 2.20%.